Okay, this is another module that I've created in the holistic adjustment technique. And I'm going to do a brief demonstration of what this looks like in practice. And I'm not going to be able to really go into all the details on this, but I did want to show you kind of how it all fits together. If you're asking yourself right now, what's the holistic adjustment technique? Never heard of that. Well, I have, I believe, 9 previous modules that I have recorded to introduce this technique, talk about the theory behind it, a lot of honestly, some of the fallacies that we have all labored under in the specifically the idea of supporting adjustments. So why are we supporting adjustments? Well, if we're doing the sales comparison approach, that's a hedonic valuation model. So what we're doing with that type of valuation model is we are separating out units of utility. I call them pleasure units in a property, and we need to take each unit and just notice differences. So when we're looking at a comparable property and our subject property, we always want to begin by not looking at the price. We don't need to look at numbers yet. We just need to look at property to property. What are the differences? And how does the shape of our market, how do market participants react qualitatively to these? So right now we're not talking about how much do I adjust for X. It doesn't matter right now. What we need to say is I need to notice qualitative differences if the shape of my market is such that my market cares about that. Um, let's just take Comp 2, for example, right now. Comp 2 has an adverse traffic influence. And so I need to qualitatively notice that there is a difference there. And the market cares about that. How do I know the market cares about that? Well, because I've observed the market reacting to traffic influences my entire career. And so I need to be able to bring that Bayesian reasoning to bear right here. I don't need to start with, well, I only start with data and I need to let the data tell me if that's important. No, I need to tell the data that this is an important difference, and any model that recognizes feature differences and attempts to quantify those needs to model in that sale 2 is inferior in location. So how have I done that? Well, I've just noticed the difference and I've structured it. So I've put in -1. So I'm structuring based on the subject is always the reference point. It's 0. And so when I need to structure something, the subject is 0. Whatever the subject is, that's 0. And so inferior is -1. If it were superior, I would say +1. And so, and sometimes there may be intervals in that difference. So if we look down on patios, the subject again is the reference point at 0. But the reference point here was an oversized covered patio. And so if I'm looking at the reference, sale 1 has more of a standard, smaller covered patio, so it's inferior. Sale 2 has a very similar extended covered patio. It's 0. Sale 4 just has an open patio. It doesn't even have a covered patio. So it is an additional tier inferior. So I'm structuring that as a -2. So I need to recognize that there are some implications in structuring. So what I'm saying by that is the difference between the subject's extended patio and a standard patio and a standard patio and an uncovered patio is an even interval. I may not want to structure it that way. I may have plenty of experience to bear to say, well, there's diminishing utility for these covered patios. Yes, people want to have a covered patio. It is something that brings additional pleasure, brings additional utility, but there's diminishing utility when I double the size of that patio. It doesn't necessarily double the value. that's a completely legitimate, more than legitimate, that is a great way to say that I'm starting with what's the shape of my market? How does the market react? And I have to bring my competency, my experience as an appraiser to bear before I begin modeling. I have to consider the shape of my market before I try to work with my data. So that's super important because you can't just let your data tell you what your market behavior is, because the data is too messy. We've already talked about this in other videos. Too many variables, and there's really, for all practical purposes, there's too many explanatory reasons why prices can be what they are if I'm not really structuring my data in terms of the differences. So I've done that with several different things. Some are easy to structure. Gross living area is already structured. It's already numerical and something I can work with. It's in an interval that makes sense. So now that I have made qualitative observations, now we need to work with our solution space. So what we're doing here is we are defining our solution space, and then we're segmenting it. That's what I spoke about in maybe a couple of videos ago, was the need to do that, and then we can explore the solution space. So here we are defining the solution space right here. We want to know the highs and lows. So this is our Bayesian reasoning, Bayesian priors, when we talk about that traffic influence, that location adjustment here. Like I said, it's not my first experience with this, and so I need to note, based on research, experience, prior observations, what do I think how should I define the solution space? So here I've got it as 4% to 8%. So I believe that the market reaction is going to be more than 4%, and I believe that it's probably not going to be above 8%. Now I could test that, and I may want to refine that. I may find that once I begin to feel the tension between the data and my qualitative and Bayesian reasoning, my prior knowledge and experience, my prior research that I've done, what is it telling me? So we can do that all the way down in terms of setting our highs and lows for each item. Now, note for bedrooms, my low is 0. I don't necessarily know if the market's going to react to bedrooms. Is that going to move the needle outside of gross living area? In my market, it often does not. But I'm able to actually see if the best possible adjustment set includes a bedroom adjustment or not. And so I'm including these potential variables even because they're a difference. So now I come to step size. For each one of those, I'm segmenting that solution space for each variable. So here, if I've got a location difference from 4% to 8%, I have a 3 possible option solution space for that individual variable. I'm doing that all the way down. Well, I've got quite a few differences here that have to be modeled. Well, when I actually look at the product of all those options, the way I have this solution space set up right now, there are 58,320 options. So think about the magnitude of testing that many solution sets or adjustment sets. It's too many. And so if I were to instead just take each one individually, So if I were to say, okay, I'm going to start at the top, I'm going to work at location. Okay, let me see between 4 and 8%, which seems to work the best. Well, what I'm doing is, by definition, I'm modeling for every other adjustment below location. And as I move down, I'm modeling for every other adjustment above location. And if I'm starting at 0, you're modeling in a way that you know doesn't reflect the market. If I'm starting at the top and working my way down, well, I'm essentially saying gross living area is 0. Well, do I think that the market doesn't react to gross living area? Well, no, I've got tons of support for a reaction to gross living area. So I can't just iteratively work my way down. I have to consider the complete adjustment set. Well, I have 58,000 plus options, and some of these only have, 2 or 3 possibilities within that solution space. So how can I work with that and actually find the most coherent adjustment sets that are the best explanation both for the data, for the quantitative differences, because now we're going from qualitative to quantitative, but I cannot violate the qualitative. So I can't just ignore an adjustment because maybe it fits the data here. Well, if it doesn't fit the shape of my market, if it were to happen in this particular case that for some reason that traffic influence comp was kind of a high outlier, hey, well, it looks like it would be better if I just made no adjustment for that. Well, but that's violating the qualitative differences that I've noticed and the shape of my market, and I can't really support that. That's not logical. So, how do we then deal with this overwhelming number of possibilities? Well, we're going to do that by sampling. And so what I'm going to show you next, I'm going to remove myself from the screen because I've probably already blocked a few things here from your view. But what we're going to see is, again, if it was blocking, there's 58,320 possibilities right here. That's just a product of all of these individual adjustment solution space criteria. And so now I want to sample and make some observations from my sample. So I'm going to move to this screen right here, and it's a little hard to see. I'm going to zoom in a little bit so you can see. So how have I sampled this? What I've done is I've taken 1,000 possible adjustment sets at random. So I have randomly sampled the 58,000 1,000 times. And then I have ranked those, just like I did in the last video. I have ranked them by a confidence weighted standard deviation. We'll talk about how the confidence weighting works another time. And what we're looking for now is not just, okay, what's the top adjustment set? Because that's not really as important as, well, what's the entire region? What are the properties of that whole region for all of the best solution space options? So how have I essentially been able to take the entire solution space, sample, and then look at, just like we did in that last visualization, I want to narrow down to just look at sort of the best set and see what are the properties of value that are implied from that space. And when we look at it that way, it's far more instructive than merely just looking at one single adjustment set. So it's very interesting when we do this, how to evaluate our best sets. So here you're seeing in this chart, these are the top 20 out of the thousand, so it's the top 2%, and by top 2%, I mean the most coherent, the lowest confidence weighted standard deviation. And you can see over here, out of that 58,000, I've actually achieved a shockingly low confidence weighted standard deviation. There are a lot of adjustments here, but it's actually not too terribly complicated of a market in terms of market behavior is not terribly erratic in this market. So we can see that just like I've talked about before, when we look at two nearly equivalent adjustment sets, they can be different in quite a few ways, but achieve a very similar result. So if I'm looking at, let's just take these top two. Well, they were both at 6% for the location tier. In fact, the entire top 20 were. And if we're looking at, let's see, site size was almost all 10s, but there were a few 8s in there. But we can't look at those just in isolation. It doesn't mean, oh, 10's the best adjustment. Well, 10's only the best adjustment for site size in the context of the other adjustments. So here, 8, if I'm looking at this adjustment set, 8 is the best possible adjustment for site size given all of the other adjustments. So we need to keep that in mind. So between these first two, we can see that for that quality difference, one was $25 a square foot, one was $30 a square foot. Well, it doesn't mean that 25 is better than 30. It means that, well, 25 is the best quality adjustment when I'm adjusting $4 per square foot per year of effective age, and I'm making $0 adjustment for that bedroom, $6,000 for the full bath, and $80 a square foot. So again, we need to look at them in context. So this near equivalent second adjustment set here, well, it's $30 for quality, $4.50 per square foot per year of effective age, and it does have a bedroom adjustment and a higher bath adjustment and a lower gross living area adjustment. So we can see that those all are important. So even when it comes to the pool adjustment, well, there's a big difference between the first adjustment set and the second adjustment set in terms of that pool adjustment. But now let's look at values. So all of these are reconciled with a statistical z-score weighting reconciliation method, and you can see that even though all those adjustments were quite different, the region of where the value is very similar. We can see that that's 538,843. I know it's small on your screen, but again, we're sort of just getting the big picture. And the second one's just about $2,000 different. So we had differences in adjustments in quite a few different areas, but the end of the day, the indicated value, the reconciliation for that specific adjustment set, the grid that's associated with it, is less than $2,000 apart. And you can see that if we look at the whole set of the top 20, well, the average indicated value of that entire top 20 set is 538, so that is a very different way of looking at value, at what adjustments mean, how can they be applied, because they can't be applied again in isolation because they all impact one another. Those first two do such a great job of really taking that into consideration. Now, does that mean that I don't try to work with this? Maybe. What I want to do at this point is to look at maybe where my solution space feels like maybe it's too wide, or maybe it's too narrow. Maybe I've potentially excluded things. So site size is a great example for this one. I've got my solution space capped at $10 a square foot. Well, most of the adjustment sets that were the best adjustment sets were at the top of the range. Does that mean I should I should expand my solution space there? Maybe or maybe not. So it could be that there's some correlation between the site size and something else, and or it's just noise in the data set, and there maybe is an outlier that's a larger lot sale that is really making it seem like that the solution space should be expanded when maybe it shouldn't be. So that's where there's always a tension. And so I want to talk to you again face to face. We always have to live in the tension between what maybe the data for this particular assignment, it's how this data is structured as a whole, and what we believe is the best reflection of the market. We should not try to artificially get our standard deviation to zero, have every sale adjust to the same number, because that's not actually recognizing the reality of the market, in that if I take any given property and I sell that property 1,000 times, just take different buyer, different seller, same market, same day, and I put that same house on the market over and over and over again, it's not going to sell at the same price. There's going to be a natural variation. There's going to be a natural distribution, with market value representing the peak of that distribution. But we cannot artificially make that distribution go away. And so that's really important to recognize, because we have to respect the fact that there is uncertainty in a market. There is going to have to be a recognition of probability. And for that, we can't just try to make probability go away. We can't assert certainty where it doesn't exist. We have to instead assert a market, assert a shape that is a well-informed shape of how people are actually behaving. And within that, we should expect there to be some uncertainty, there to be a distribution that emerges. And that is what market value is. It is the most probable price under a series of assumptions. And that's going to be the peak of that distribution. So again, this is just a brief overview. There's a lot of things going on here, and you do see this in an Excel workbook. That's how I use it. The holistic adjustment technique is not a workbook. It is a method. And so what I've shown you, I want to be able to be constructed in many different frameworks is my ideal. The reason that I have patented this method is because I want to be able to try to make this available in a more public and open source way. I want to be able to share with you the inner workings of this. And I want you to understand what's happening here, because I believe that this is fulfilling a need that we just didn't realize that was there. We've often taken the idea that, okay, I made an adjustment and it seems like it's a better fit. Well, it probably is. But is that the best adjustment set? Is that the best adjustment in the context of all the other adjustments? And we haven't had a way to answer that question. We haven't even been encouraged to ask it. And so, this, I believe, is going to create a way for value to be seen in a context that hasn't been possible before. So we're going to see, to be able to see a collection of possibilities, a sampling of a number of possibilities that we couldn't possibly test in any other practical way. And so I submit this as something for your thought and discussion questions. And if this is something that you would like to see available in in your analytics software, if you want to see this available in your education, and you want this to be available for use in your practice day in and day out, I want to make that happen, and that's really what the goal that I'm working toward with this method. So I know this has been a long video. I really appreciate you watching if you've made it to the end, and feel free to reach out to me with any questions.